Hi, so today I'd like to show you how you can create a curve folding simulations using Vellum Houdini. Since there is no default constraint or forces in order to simulate the folding and for the Vellum structures or Vellum objects, I have to create a custom constraint somehow. But I found out there's a way to customize the existing constraint, or you can create constraints from scratch as well. So I'll show you this time. I'll show you how you can customize, how you can modify the current existing constraint so that you can use it for the folding. And for this example, I'm going to show you how you can create a curve folding by modifying the constraint. So let's get started. Let's start by creating a geometry node, and I'll start by creating a null node so that I can contain all the parameters that I'm going to use for this examples. Okay, first of all, I am going to create a float for size of the plane. Maybe the range from 0 to 10. Okay. And also a resolution of the plane, which will be affected for the visuals of the final result. Quality. Also, since we're gonna have to create a curve as well for the folding, let's create some parameters for the curves. So first one, we're gonna call it curve offset, which will be the offset value for a sine curve. I'll just set it as 0 to 10 for range. Okay, another one, I'll call it curve height. So that will be height of the wave, sine wave. And that will be around 0 to 1. And also I'm gonna create a curve wave, which will be used for a frequency of the wave. And I'll just set the range from 0 to 10. Okay. And finally, I am going to create another parameters, which will be an angle for the folding. So the folding, I might want to set up around minus 180 to positive 180. Okay, around that. Okay, so let's get started. Let's create from the grid, and I'll copy the size. I'll just set the size to 2, maybe the resolution to 30 something. Curve offset, I'll just set randomly, angle, maybe some 90 degrees or something. Right, I'll copy this parameter first and set it to the size of the plane here. And also I'm gonna set the resolution of the plane, which is shown here. Maybe just the rows. And for the column, I'm just set to 2. So I'll have like a single column that's several separated row plane, like this, to make it really simple setup. Okay, let's go next. And also I am going to create a curve. So I'm going to create a line first and set the size of the line to the same size as the plane. So I'll set the rings to linked to the size and also direction. I'm going to trace the line to the Z direction, so I'll set the direction to Z like this. And I see a curve here. Yeah. Let's set the background to black so that I can see a little bit more easily. Okay, I don't see that much. I see now. Right, so I have the curve here. It's not on the plane right now, so let's move this curve half size of this length. So I'll copy this parameter and set the origin here as the relative to this distance minus distance times 0.5, so that everyone will align to the centers. Also, right now the line only has 2 points, so I want to have the same points as this number of rows. So I'll copy this resolution again and set it to a number of points here. And now I have this point on the exact same position as the row lines here, the seeing lines here. Right. Now, let's make some wave out of this line using point wrangle. Okay, let's just make it simple. First of all, I'm gonna get some parameters from the controller. So see, float offset equals CHF offset float height CHF height, and also float wave CHF wave. Okay, and promote that parameters, and let's copy those values, curve offset, paste it to here. Just do the same for everything and rename it after. So this one will be curve height, and this one will be curve wave. Okay, so let's make a float value using sine, and inside a sine I will use a point position, the Z value of the point position, and let's scale it using a wave value. Okay, and after this, let's add an offset value inside a sine. Okay, and after that, the sine range will be -1 to 1, so I'll multiply it by height, and let's see, let's assign that value, the val variable, to the x position of the point for the lines, for the curve. So let's see. Okay, I got an error here. Okay, small mistake. Right, so seems I got the curve. Let's check if I change the controller here, the plane underneath. Okay, so I do got some sine curve here, and okay, yeah, looking good. So what I want to do is that separate those plane underneath into the left side and the right side, and I want to use this curve as folding crease, so that the paper-like material will be folded upward or downward to create a mountain based on those crease. So in order to do that, first I have to split the plane. So let's do that by using a poly split node. And since I want to split this plane with this curve, I'll just connect it like this, and I think it has been splitted. So before I had 29 primitives, and after that, after splitting, I have 58, so 2 times, which seems correct. Just in case, just to make sure, I'm just gonna fuse the points so that there's no duplicate points on the middle. Right. And let's see. Now I wanna split those planes into different groups and make an ID like for each group, like for the dependent on which row they exist. So this one will be the first row, the second row, third row, and so on. And this is the left side plane, and this is the right side plane. This is to create a constraint, or to modify the constraint in between those two planes, which we're gonna have to modify it to set an angle. Okay, so let's do that by first. Let's sort out the primitive by X position first, so that I can split the left side and the right side. And also let's create a bound node, and after that I am going to use some primitive wrangles in order to set which ones is on the left side, which primitives on the right side. So I will make a primitive wrangle here, and I'll name this sort X. Okay, and I'll place the sort node to the first input, the boundary node to the second input. Okay, then if I'm gonna write it as if a prim num, so the primitive number, these should go first, so the first row could be 1, first row could be 2 or something, but must be less than 29 because it is sorted as on the X direction. So all these primitives have an ID less than 29. All these primitives on the right side have IDs larger than 29. So considering that, I can create a condition like n primitives, which is the number of primitives, which in this case 58, divided by 2, which means 29. So if the primitive number is less than 29, I can set the prim group to left side. Right. Okay. I think the text is a bit too small. Let me pause a little bit and change the size of the font. Okay, I think it's a little bit better. Okay, so I have changed the left side primitive. Also, let's change the color so that I can see the difference. So I'll set the left side to red. Okay, let's see. Okay, so this side was the left side. No problem. Okay. And also let's set the right side. So set prim group right prim num, and also the color, I'll set it to blue for this one. good. Now, next thing I want to do is to sort out those primitives on the left side with the row direction, so it means z direction, and do the same thing as for the right side as well. So let's do that by first splitting the geometry primitives to the left and right. To the left side first, and sort out primitive by z direction. And do the same for the right side as well. Okay. And also, let's promote this primitive number here, which is these values as an attribute, so that we can use it later on as an attribute. So I'll use primitive angle for the left side. I'll just call ID, promote ID, and ID equals to prim num, which will be an integer value, and do the same for the right side as well. Okay, now let's see. I go look at the primitive. I got these ID attributes, so it's fine. Then let's merge this all together. Right, now let's go back and fuse this since it has been separated. Let's merge the points, and also let's create an attribute promote to promote the maximum of the IDs, maximum number of IDs, which will be used for each loop later on. So from primitive, I want to promote an ID to detail the maximum, and let's change the name to ID max. Let's see, detail, I have 28. 28 means is the number of IDs, so it starts from 0, so actually you have 29 primitives on each side. So you can remember that. Now, let's set that to name as base using null node. From here, I am going to start using a Vellum constraint. So in Vellum, you have a bunch of constraints, but unfortunately there's no Vellum fold constraint, so I have to somehow modify some of the constraints so that you can use it for the folding. And in this example, I am going to modify this one, Vellum configure close. So place that, and for the first input, I am going to input this geometry. Okay, let's look into it. For parameters, and basically I am not going to touch stretch constraint. I'll just use it as it is, but I am going to modify a little bit of bending, which could be used for the folding later on if you modify it. So let's look into it. And there is a parameter called stiffness here, and it says 1 times 0.0001, which is pretty small value, which makes clothes really soft. So in this case, I want to make the plane like an origami paper-like hard stuff, hard material. So I'm gonna have to make it a little bit more stiffer. So I'm gonna set it to 1 times 10, something around here. And that should work better. And also, after you have set up the constraint, you also need to have a Vellum solver. And let's just connect all these together. All these three. The third one is the collide geometry, collision geometry. Second one is the constraint geometry. We don't have one yet. So I'll just keep it as empty. And now the simple setup for the plane has been done, but currently it doesn't have any folding constraints. So what it does, it just folds with the gravity. Okay, what's this? Sometimes it happens. Okay, so it just folds. I don't want the plane to fall off, so I'm gonna make a ground at the 0, 0, 0 position. Okay, let's make it a little bit lower, something like minus 0.05. Okay. Now it just falls on the ground and doesn't do anything, so now this is the time I have to modify some constraints so that I can control the folding, bending forces so that you can simulate the bending. So what I do is that if you look into this constraint geometry after close, you have a bunch of curve geometry which each primitive comes with the type of the name of the constraint, as well as some values which describes the strength of the constraint, type of constraint, and so on. And basically what you have right now is two types. One is distance and another one is bend. So distance is used to keep the distance between those lines, crossed lines here. So if I just show the distance constraint, I equals to distance. So you have those curves, and each curve is a single line, I think, and used to preserve the length of this line here for this close, which makes the close keep this as the same size. Even if it stretches, it tries to stay on the same size. So that's the distance, and the bend is used to preserve the angle between the curve. And currently you have a bunch of curves here, so it's a bit hard to see, but if I just take one geometry, one primitive out of these bend constraint, let's just take one. So you see that you have one primitive which has 4 points over this close, the primitive of this close. So it is this single constraint is over those two planes on the paper geometry that I made. This means is that the folding occurs, the bending forces are used in between these two primitives right here. So if I change the number to pick, like this one. This one only, the bending only occurs on a single primitive, since all the curves are inside one primitive. I change the value again. And now this one, the curve, those 4 points here are on the 2 primitives, which is on the same row. So this is another constraint which is used to preserve the current angle. But in our case, what we want to do is to change the rest angle for this kind of constraint so that you can customly control the angle, the force, the angle of this angle between those 2 primitives, which is on the same row. And you can do that by modify this constraint, this specific constraint which is on these 2 primitives, which is on the same row. And what you have to modify is just some simple attribute value, which if you look at the geometry spreadsheet for this current single constraint, there is some value which corresponds to the rest angle for the bending. There is no attribute named as rest angle, but there is a name called rest length, and this rest length is actually used for the angle force angle constraint. So if I could just modify the rest length also as rest length original strength orig attributes to a specific angle, then actually I can control the folding angle for whole piece. What you have to keep in mind that you only need to change these rest angle for the constraints which is on the same row, which is a pair of the left and the right side, and the left and the right side in the same row. If you set this rest angle for other constraints, other bending constraints, then the mesh will just mess up. So what's important that you just pick up all the rows, all the same rows, the 2 primitives, and pick the constraints which is on the same, the 2 pairs of rows, the pairs of primitives on the left side and right side. So in order to do that, it's a bit tricky, but in this case there might be a better way, but I'm gonna use a for each loop to actually do that. So I am going to make a for each number loop, and I'll connect this to a input for each begin, and also set the gather method to feedback each iterations, because you don't want to add new constraints, you just want to change it. Also change this to fetch feedback, right? And also for the number of iterations, you actually just want the number of rows here, which in this case 29. So I gotta get the number 29 somewhere, but I have already set the detail attributes as 28, so if I add 1 to this value, then it will be 29. So I'll get that number by calling a h script here. So in iterations, I'll call detail /base, and for the attribute name, it's ID max, and first value plus 1, and should be 29. So let's set up for each value, and for the output, I'll just connect it to a Vellum solver right here. So this is the important part, how you can modify it. Well, I already said it, but in this case, we have to search for a pair. We have to search for the constraint from a pair of primitives left and right for each column, for each row. So first we're gonna get, for each loop, we're gonna get each rows as a primitive, as a geometry. So I am going to use a primitive wrangle here, and I'll name this get row. And from this base geometry, using iteration detail attributes from the for each count node, I'll write some simple code so that I can retrieve a pair of primitive left and right for each row. Okay, so if an ID of the primitive is not equal to the detail attribute of the second input, named as iteration and I will remove all the primitives, remove none. Also, let's delete the point. And I got the last one, I think. So let's connect that to the end for each end and see if I really got each rows by checking the single pass. And yes, I seem to get each row with a pair of primitives left and right. So that's good. Let's go back, uncheck the single pass, save it, and just to make sure, let's fuse this so that we don't have duplicate points here. I don't think we have right now, but just in case. Okay, so the main part, how to search and modify the constraint. Right, so I am going to make another primitive wrangle. This time I'm going to modify this one, which is a constraint. Should be a constraint. Yeah, these values, and out of these lines, primitives, I have to search for a bin group as well as the group that is on the specific rows of primitives. Right. So let's go back, and first of all, let's filter this primitive by setting a group. So first of all, I only need to, okay, okay, first of all, I have to set it, this one, to the end. And let's go back. What I want to filter out, I only want to search between the bend groups, so I'm going to set it to bend, and let's write coding. It's going to be a bit of coding here, so I'm going to open the editor. Okay. First of all, let's get the primitive, all the points for each constraint primitive, constraint geometries using prim points. Okay, also let's make some flag which to use it for final decisions whether this is a good to go constraint or not. Okay, also let's make an empty array used to check if the array, if the points is, all the points are in the single row which I have got from here, right? So I'm gonna make an empty array, which is an integer. Okay, so let's make a loop for each point on the primitive. Okay, and first of all, I want to get point position for each constraint point. So I'll use point function on p position yes I, and also I'm gonna use a near point function to check if the point is on the chosen row. So I have to input this geometry here to the second input so that I can use it for a near point function here. So whether if I found a near point, if I'm looking at this constraint, if I use the near point, then all the points will go to the nearest primitive, and if I have the distance in between those points and the primitive, then that means the point is not on the primitive. If the distance is 0, then it is on the primitive. So that's how I can check whether the point is on the primitive or not. Okay, so after I did the in-prim near point, I also want to get the primitives of the near point. So primitive numbers of the near point. So whether if I'm looking at this constraint and I am looking at this point, and if I do a new point, obviously if the geometry is here sticking into this geometry, then the point will be stick to here, and from here I can check what kind of primitive I have is for this point. And currently I only have this red primitive, which is the left side primitive, only the right side primitive. But if the constraint points started from here and do the near point, then I have two primitives attached to this point, left and right. So that's what I want to check. Thing is that I have to find a constraint not only on the left side, not only on the right side, but both the left side on the right side. So what I want to do is that check if the near point is on the left side, on the right side, on the middle side, and see if all the points are distributed to left and right, so that I can use it for the folding, not just on the single primitive. So that's what I'm going to do now. Use point prims and pt, and if the length of the primitive is equal to 1, which means on the left side, on the right side, then let's make another condition, find and prim r, which I made it here, which is currently empty but soon filled with the primitive value, primitive IDs. So if it's on the left side or if it's on the right side, obviously you have only one primitive ID, so let's check if this ID is already contained in this array by using the find function. If it's negative, which means if you could not found it, then push this value to this array so that I can check later if the point is already found on the left side or on the right side. Okay, now let's leave the condition. Let's make a endPos, which is a position point position for the near point. So, which is on the second input, and t is the position of the point. And let's get the distance between the position and the near position. Now if the distance is larger than 0.01 or something, which is pretty low value, means the point is far away from the rows which I want the constraint to be inside, so we cannot use this constraint for this primitive set. So I'll set the go as 0. So if the go is 1, then we can use that constraint for folding. Now, after that, I will check the lengths of n' r, which I created here, and added the points prim IDs here. So if the number of prim IDs contained inside this array is less than 2, meaning 1, so it could be 1 or 2. If the point is if the constraint points are both on the left side and the right side, then the number of primitive r should be 2. But if the constraint is only on the left side or if only on the right side, then this number should be 1. So if the value is 1, then if the constraint is not crossing the primitives as a pair for the folding, so which cannot be used for the folding, so I'll set it to go. I set the go as 0. So now the condition is ready. If the go is equal to 1, then I can set the angle for this primitive, which I'm modifying using this primitive constraint, primitive wrangle. So I have to change two value, one rest lengths, and I am gonna use some parameter here. I'm gonna name angle, and also rest length bridge, which is used for scaling later on, so this is also needed. And I'm just gonna use the same value here. So I'm gonna copy this and apply. Okay, and let's check if I got any errors or not. Seems okay. Let's go out the loop and check geometry spreadsheet, go to the primitive, and look at the bend group and see if there are some primitive which have value 45. No, sorry. Currently I don't have any angles, so I have to promote the value, and let's copy this angle value 85.6, copy this and paste it here so that I can actually control it on a controller null node. And let's go back again to the geometry spreadsheet, and I see some constraints, rest lengths and rest lengths original has been changed. And let's check if those constraints are really crossing those primitives, crossing this folding line, folding curve. So just to make it easy, I'll just use delete when rest length is equal to 85.6, and yep, I do have a constraint which is crossing the plane, so that's good. I have successfully made constraint, I think. Yeah. Now it looks good. Let's go back and change it here. Now everything is almost ready. If I play it, then the bending has been done. And if I change parameter, like the angle to the minus 126, change the curve, something like this, and play again. Whoa. And again. Pretty easy. Now you can see that the animation is a bit too fast, makes the cloth a bit broken up. So let's make the animation a bit slower so that it will gradually change the angle and wouldn't break the cloth object, the Vellum object. So let's go inside the Vellum solver, and I am going to create a constraint property, Vellum constraint property, and I am going to apply only to a group of bend. And what I'm going to change is this rest length scale, so and which is used to multiply the rest lengths to actually calculate the rest angles, in this case for the bend. So I'm gonna make a keyframe, like when starting from 0, maybe from keyframe of 10, I'll keyframe it to 0, and then when it gets to a key 50, I'll set it to 1, which is a full value. Okay, frame setup, commit change. Right. Now let's see what happens. Let's increase a little bit of resolution here, and let's play. And gradually it changes and folds. Nice, nice. Now Let's finalize this by put in a color to white. And also let's add a facet so that it will create a crease line when it bends. So I'm gonna check the custom polygon here, and that's about it. Let's change the parameter again. Maybe make some big wave here. Okay, this looks go. It's okay. I'll set it to angles something like 73. Let's go. And voila. Nice folded plane we got here. Now let's hide the lines. Increase some resolution here. Okay, again. Nice. Yep. So that's how you can create this kind of curve folding simulations using the Vellum by modifying a constraint by yourself, manually, customly. And knowing that you can actually control this constraint using attributes, I think there's a lot of possibilities using it to simulate a whole bunch of simulations you didn't know you could using Vellum. So I hope you enjoyed it. I hope you learned something here. That's it. Thank you.